All right, let's go through this example of this input-output table and look at some of the patterns that we see, practice filling in the missing values in the table and answering these 3 questions. So if I'm looking first at this table, I notice there's a missing value here at the top of the table. I've got inputs 0, 1, 2, 3, 4. When I look at my outputs, I have nothing, 4, 9, 14, 19. First thing I want to do is look for a pattern that I see between 4, 9, 14, and 19. And I want to see what is that changing by. And I want to see if it's the same number each time. So when I look at 4 to 9, I know that at 4 plus 5 gives me 9. So I can actually fill in here that this is increasing by 5. Okay. When I look at the next one from 9 to 14, again, I notice that's increasing by 5. So I'm going to fill that in here as well. Then from 14 to 19, 14 plus 5 again is 9. That's also increasing by 5. You don't have to write plus 5, but I like to write the plus 5 so I remember that it's increasing. It'll also hopefully help me remember to write a minus sign when it's decreasing. Now, since I have this missing value here at the top, I can use this pattern that I know that's increasing by 5 to figure out what number would go here in order to increase by 5 and get to 4. Okay, so I know that it's supposed to continue increasing by 5. I know that from here, from here to here has to also be an increase by 5. So I need to think back. Actually, I could work backwards. I could say from 4, I need to go backward 5 in order to know what the number was. So I'm going to count back actually on my finger. So I'm at 4. I'm going to go 3, 2, 1, 0, negative 1. So I was at 4 and I did 3, 2, 1, 0, negative 1. So 5 numbers back from 4 would be negative 1. So the number that must go here is going to be negative 1. Now, is there like a mathematical way to figure that out? I can think in my head what number plus 5 gives me 4. It's a little hard because 4 is such a very small number and 5 is bigger than it. But I can also think about, now that I have the number, I can double check it. If I'm at negative 1 and I'm thinking about hopping on my number line, negative 1 to go to, if I go add 1 to it, I get 0, 1, 2, 3, 4. So from negative 1 to 4 is 5 numbers. If I'm thinking about it on the number line, it would be like 5 little hops. Okay, so that is my negative 1 goes with my 0 input. That's my output for my 0 input. Now, I know that it's increasing by 5 consistently through this table. That's how I was able to like work backward and figure out this missing value. If I had a missing value below the 19, I could increase by 5 again and know that my next number would be 24 and then 29, etc. So I can extend my pattern either way. I just have to remember when I go this way, I'm kind of like working backward. So we've actually answered some of these questions right now. So the first question is, what is the initial value? Now, you'll remember when we looked at our, we had a notebook page about this that talked about arithmetic sequences, common difference, initial value. All of these vocabulary terms are on that notebook page. The initial value is our starting value, and it always starts with 0. So when I look at my table, I am very lucky in this situation. I have a 0 in my input column. And so that means that the initial value, or where this starts at figure 0, is negative 1. So for this situation, my answer for the initial value is negative 1. Okay. Now, the way I got that, let's remind ourselves, we got that by looking here. I want to change that color. The way I got that was by looking here in the table. My initial value was this number. Okay. And my initial value was this negative 1. So where does the pattern start? At -1 when the input is 0. Okay, then it counts by 5, by 5, by 5, by 5, by 5 extension. So what is the common difference? Well, the common difference usually means subtraction, so it's how much is it changing by. The common difference here is 5, because I already figured that out at the very beginning. So common difference, you guys have been figuring out forever. You're just not quite sure what the word is or what the vocabulary term is. But here, D equals 5, positive 5, because it's increasing by 5. That's all I have to do when I'm being asked that question. And then bonus, what is the expression for this table? In that same notebook page, we saw how the initial value and the common difference help us build the expression. So this common difference is the number, becomes the number in front of our variable. So our input variable here is x. So if I go down here to create my expression, it's going to become a coefficient. So it's going to be a 5 in front of my x. And then my initial value is what happens at the end, which is a -1. So I'm going to just do subtract 1. So our expression for this table is 5x minus 1. I take each input, I multiply it by 5, then I subtract 1. You can check it real quick right here with this 2. If I do 5 times 2, I get 10. If I subtract 1, I get 9. 3 times 5 is 15, minus 1 is 14. 4 times 5 is 20, minus 1 is 19. 5 times 1 is 5, minus 1 is 4. 0 times 5 is 0, minus 1 is -1. Can sometimes be a little tricky to check with the zeros and the ones, so I like to check with the other numbers first. But there you have it. That's how you find your initial value, your common difference, and how you create your expression. Thanks for watching. Let me know if you have any questions.